starts at 7 or 1900 over here, where the breakfast is. If you don't know where that was, if you're not in the hotel, just go around. Our next speaker is C.Y. Lowe on Oversights of Einstein Maxwell and their insanity. Their errors. All right, C.Y., have some fun.
Today, I'm going to talk about Einstein's mistake. But please do not take me as an attack of Einstein. I admire Einstein greatly. He's probably the most admired physicist I have. But admiration is something because he was an adventurer to do the pioneer work. But a pioneer work has never been perfect. So I'm talking about is why Einstein is not perfect. And besides Einstein's mistake, I also have done some favor to Einstein. Einstein said there's a unification between electromagnetism and gravitation. And he was not able to do it because he, unlike Maxwell, didn't realize a unification needs a new interaction. And I find out there's a new interaction, the charge-mass interaction is necessary for the unification. Therefore, I complete Einstein's work for the unification of gravity and electromagnetism. And this unification is very important because it will turn the physics many areas upside down. So now I'm going to talk about Einstein's equation and formula EMC squared are not always consistent. The reason is EMC squared is talking about the energy and mass are equivalent. But Einstein's equation shows the electromagnetic cannot affect the curvature R, but the mass system can. So therefore, they are inconsistent between Einstein's equation and Einstein's formula. And another thing is, the photonic energy is equivalent to mass, but the electromagnetic energy is not equivalent to mass. Therefore, the photon cannot be contain only the electromagnetic energy alone. It has to be contain something else. And what happened, find out from general relativity is it also contains the gravitational wave component. So Einstein has another mistake. He takes the gravity, the electromagnetic he takes the electromagnetic wave as the photon, but actually it includes the electromagnetic and gravitational energy. Two together, they form the photon. Another one is the easiest one to prove. Einstein came, if you have because EMC squared, you get any piece of metal, you heat it up. And because you heat it up, you add energy. And because adding energy, then you increase the mass because EMC squared. And because increased mass, you have increased weight. That's Einstein said explicitly in his interview with Science. But I have done the experiment, other people have done the experiment, the Russians have done the experiment, the Japanese have done that. What happened is, we totally test 6 kinds of metal. And every one of them, if you measure it after heat up, it always has a reduced weight. So, without question, Einstein's wrong. Because the final judgment of physics is experiment. He has a question, how do I know your experience is right? He asked me to send him a video. Well, even video, you can make it up. So my suggestion is you go home and do the experiment yourself, because a electronic scale costs only $500 now. So it's very cheap to prove Einstein. Oops, let's go. Oh, I see. As I said, as Whitehead pointed out, and the worst homage we can pay to a genius to accept uncritical formula of truth which you owe to it. That's Whitehead. I quote Whitehead, and I also believe he's right. And now, the next thing is say the inconsistent of Einstein equation and the formula E equals mc squared. Now, this one is Einstein's equation, the one. And the next one is, if you this is the curvature tensor, and the curvature tensor is the curvature tensor because G equal to 4, and the R equal to G T mu nu. And this one cannot, because electromagnetic tensor equals 0. Therefore, the electromagnetic tensor cannot express any change in the R. But a massive tensor will change it. So therefore, according to the equation, the Einstein equation and the formula of Einstein's formula are not consistent. So theoretical not consistent. Therefore, one of them has to be wrong. And what I find out is because the Einstein equation has many predictions beyond what we already know. So it's unlikely Einstein equation is wrong. It's E equal mc squared is wrong because E equal mc squared has never been proven. Nobody has ever proved it. Einstein proved for the case of a photon has problems, but he tried to prove a general proof from 1905 to 1909, he failed. So this has never been proven. So it's likely the E equal mc squared is not correct. Now, then I talk about the problem of photon. The problem of photon is, Einstein said, if you have any angular momentum and plug in his equation, you'll get a gravity solution. So what I do is I put the electromagnetic wave angular momentum in one side. I try to get a solution for that, and I find out I cannot get a sensible equation. Penrose did get an equation, get a solution, but Penrose's solution is unbounded, so it's not correct. And what I finally find out is this is Penrose's solution. This one is not correct. And then what I find out, I have to. Now, another people say gravity is so small, so we can use the perturbation theory to do it. The only thing is mathematically, if you don't have a bounded solution, you can't use the perturbation theory. And this solution, this equation, has no bounded solution, like Penrose demonstrated. So mathematically, a perturbation approach has to be valid. It's necessary condition in Harvard that the problem has a bounded solution. And for this case, Einstein has no bounded solution. In fact, Einstein's solution itself never has any bounded solution. In fact, that is beyond. But anyway, so what you need to put to make a general relativity and Einstein's assumption of photon consistent is change the Einstein equation in the following way. The Einstein equation, this is the electromagnetic wave solution. You know, subtract a photonic energy momentum. The photonic energy momentum is necessary because the photon, if you consider as a massless particle, is inconsistent with the Maxwell equation. It's only you do this thing, and after it changes to a photonic equation, then it's consistent with the Maxwell. It's consistent with the Maxwell equation. So Einstein equation has to change. And notice that this have a minus sign, a negative sign. Actually, the minus sign is universal necessary for any solution has a dynamic solution, Einstein equation. That means Einstein equation don't have any gravitational wave solution because they don't have the minus sign. If you want to have a gravitational wave, so that's why I'm saying the people get the Nobel Prize to the experiment, but actually they don't understand general relativity. That's why. It's because Einstein equation has no dynamic solution. So in order to have a dynamic, you must add something to it. Now after this thing, then the photon is the gravitational energy plus the electromagnetic energy. That's photonic energy. It's okay. Now, you talk about theory. One thing about physics, no matter how good your theory is, you have to verify by experiment. You know why? Because in physics, we can easily put an implicit assumption into the equation and make a wrong mistake. One example is Penrose and Hawking. He proved the singularity theorem. Why? Because he made an assumption all the coupling constants have the same sign. That was wrong. So that's Hawking, and I have no achievement on her own, and he's lying beside Newton. That is the problem for the British to fix. We have no comment on that. So there are people who did the experiment. They prove Einstein EM sequence is not right because Einstein's as Einstein said, you heat up a piece of metal, it has reduced weight instead of increased weight. So that's what, and this is not the only one. There are three experience prove Einstein wrong. Another one is you charge a metal ball, they become lighter. That is done by Russian. Another done by Russian is they heat up a brass metal and also get a reduced weight. Another one is done by Chinese. They did 6 metal and heat up and also reduce weight. And I don't trust them, so I didn't explain myself. I also found the weight reduction, so I have no more doubt. So you people do not have to believe me. You just go home and do the experiment yourself and find out what's wrong with that. So now it seems to be we need to explain why the hell the heat up metal become lighter. It's not heavier. Einstein say heavier. It's lighter must have reason. The reason is very simple. If you actually there's a metric called Richter-Northern metric. This metric was derived in 1916. Exactly the same year Einstein published his generative paper. And this matrix has sitting there in all the textbooks for a long time. Nobody knows what to do with it. Nobody say anything about it. Until one day I look at the thing, I say, there's a repulsed gravitation there because this is a gravitation attractive. This must be repulsive because it's added to it. And also the Q square is related to the charge. So this term I call it charge mass interaction. And because of charge mass interaction, now we remember the electromagnetism is charge and charge interaction. That's called electromagnetism. And gravity is a mass-to-mass interaction. That's gravity. Now you get a charge mass interaction. That is not pure gravity, obviously. So this concept makes the necessity of a unified gravity and electromagnetism. This term is very important. And also, you look at the thing. You look at the simple thing, and you want to you have a matrix. You calculate the interaction between the matrix and the time ago. You get this for the first approximation. You get this one. Now, if the thing is static, then the action and reaction should be the same. So in other words, if you look at you calculate the action from the test particle to the particle, then you get the opposite side, action and reaction. But the problem of the opposite side is this one is beyond the nowadays generativity, because nowadays the equation of motion is the equation of motion is the geodesic equation. And then you have electromagnetism, you add another electromagnetism there. But the Q square is nowhere within this boundary, in this limitation. So in order to have the thing be consistent, you would have to find a Q square that proportional to Q square to have that, and in general there's no such term, So, but this term I have looked familiar because I was doing 5-dimensional theory before. I find 5-dimensional theory actually have a term Q square. Actually Q square. In other words, general relativity, because its own efficiency has to extend to 5-dimensional theory. Just like Maxwell, electromagnetism is defective, therefore he had to unify, become an electromagnetic theory. And this the same thing happened. The gravity itself is not perfect. Therefore, you have to extend it to the 5-dimensional theory. And the 5-dimensional theory, I write a paper to do some preliminary work, but I didn't came, I finished the job. But it's clear that the unification of Einstein is correct from this one. And so my Einstein didn't do it because Einstein have done a unified theory of 5-dimensional. The problem is Einstein doesn't believe any new interaction has to be there. So he ignored all the things which is not happen in electromagnetism and gravity. So he failed to see there's an interaction between charge square, He ignored that, and this thing had to do and then from the 5-dimensional theory, then Einstein's unification unit is valid. So in conclusion, the charge-mass interaction is crucial for Einstein's conjecture. And now I come to the conclusion. Now it's clear the formula E mc is not always valid. The notion of photon is a consequence of general relativity. It's interesting that Einstein original statement. If the body emits the energy L in the form of radiation, the mass decrease as L over E squared is correct. But look at the L is the radiation energy, V is the speed of light. So Einstein error is he later changed the equation into instead of L equal to mc squared, he changed to E equal to mc squared. That become wrong because electromagnetism is not equal to mass. So, moreover, the existence of charge-mass interaction was derived from the static Einstein equation has been verified. And this equation is crucial for the unification of electromagnetism and gravity. Einstein should have taken all the credit because I derived everything from this equation. But he failed to recognize the charge-mass interaction. He doesn't want to believe it. He believes E equals mc squared. So I end up to be the one to have the credit. Very lucky because Einstein didn't want it. So now there's a problem. The charge-mass interaction was derived from the static Einstein and has verified. And another problem is many people expect the string theories will come up with miracles and do everything right. The problem is the string theory don't understand general relativity. For instance, the thing that Newton, he didn't do the general relativity right. And because the people in the some sort of mathematical Nobel Prize, I forgot. Anyway, they don't understand mathematics, so they don't understand it. They give Newton a prize for his work in gravitation. So in other words, Newton don't understand general relativity, and what's the prize for the
Nobel Prize?
The called mathematical Nobel Prize.
Fields Medal?
Huh?
The Fields Medal in mathematics.
The field medalists. The field medal don't understand that. And I tell people that when they write, they give Christodoulos a prize. And I say, how come you give Christodoulos all wrong? Then I no reply from the field medalists. And until in 2016, I met the chairman of the Shaw Committee. His name is Senna. I don't know how to. And I met him. I asked him, "How come you answer?" He's very frank. He said, "We don't have anybody understand general relativity." So that's what happened. So in other words, the field medalists don't understand general relativity. So Einstein is first around, since the equation is first derived by Einstein himself, so he should have recognized there are inconsistency between his formula and his equation. So I consider this an oversight of Einstein. He derived the equation, but he didn't see the equation there's a conflict. He didn't see it. And Hawking said relativity being unsuitable for microscopic phenomena. This is complete nonsense. Because photon has to be derived from general relativity. So Hawking is complete nonsense. And now the invariability is responsible to the rejection of repulsed gravitation. However, the charge mass induction is crucial to show Einstein's contextual unification is valid. And I end up by speaking with a quotation from a Chinese philosopher. There's a Chinese philosopher say, in physics, you can make a very bold assumption, but very careful about your conclusion. So the problem is many physicists have only the first half, very bold assumption, but the conclusion not very careful. So that's the thing. I hope today, I hope to tell you people, because I'm 81, I'm going to retire. I think it's your job to make the thing careful and make it well better. And that's all I want to say today. Thank you very much.
Questions?
Yeah? Yeah?
You say that E equal mc squared come from general relativity.
Pardon? Don't want.
You say,
yeah,
you note that equal mc squared comes from the general relativity.
No. I say the E or MC were incorrect.
Yes.
It's inconsistent with.
I just read one sentence you, and my question is as follows. The constant of the speed of light, c, is it local or a global constant for you?
Okay.
Because there is a big difference.
My viewpoint is...
First, in special relativity, is the condition of Einstein to have the constant of the velocity of light is not a necessary condition to demonstrate the Lorentz invariance. And in the general relativity, they don't use the constant of light or speed to make the general theory of general relativity. So my question is, because some people believe that Einstein, before his paper in 1905 or something like that, has that a first idea that C was a completely global constant of the universe, but in his writings from 19.5, 6, 7, he says that C is a constant, but only for the special relativity and only a local constant. And my question is, do you have an opinion about this? Because some people...
In my opinion...
Yeah, I will add something, because when I say that C is perhaps a global constant, it is because in some paper, some scientists used a C and in parentheses R. So they make change. They see that the velocity of this constant change with gravitation or change with many things. And other physicists did not agree about that. They say it is a strict constant. So
my answer is that I do not care to be expert on this thing. More like my opinion. I only tell my opinion on this.
Yeah.
Okay. Special relativity is an approximation. There's no such thing as no gravity exists in the whole world. Okay. So E or mc squared C is the limitation. And the C, I believe the C is constant, basically essentially constant. And I believe special relativity is correct. And that's why I want to say. And anything to do with E or mc squared, because I say the E or mc squared is incorrect. There's not much time to talk about it. Okay. And
yeah. So I have two remarks, or a remark and a question. I could have many, of course. But the first is that the Faraday tensor is indeed traceless, but it's of course the energy that you want to have that is not described by the Faraday tensor, that is the field. So if you look at the energy stress tensor electromagnetically, of course it doesn't have a trace. So the argument that the tracelessness doesn't give any mass term in the general relativity thing, I think is flawed. That is one. And the other thing is the experiment.
What's your base on say is false?
Because I've just explained that. So
no, I don't.
It's a theoretical
it.
thing. It's a theoretical thing. The Faraday tensor is a field. You're talking about energy. Energy is sort of the square of the field, or the field times its complex conjugate, or whatever you want. And then you get the energy stress tensor, which is a different tensor. That's the tensor you should compare in that case. So that argument there is just flawed.
Yeah.
It's wrong. It's a wrong
argument.
So I'm just telling you, I do not want any reaction. Take it or leave it, okay?
Okay.
Take it or leave it.
No, I expect
you don't have to agree.
No.
I'm not interested in it. I want to say another thing.
I want to talk about his experiment. I want to talk about his experiment.
Don't be too be nice to each other.
let me finish. I want to talk about the experiment. You want to talk about theory, you can do your theory. But I'm saying from the experiment, EOM situation.
As a theoretical physicist, I know that what is there, to my experience, does not add up to your argument. You have to put in the wrong things for perhaps the right argument. That's all. And I don't want to discuss that. It's just an observation. Then I have another question or observation that's about the experiment. If you say you can just go home and easily do it, a balance costs only 5,000 euros, then I'm very suspicious. I'm a very, very well-known experimentalist, and I know that if you want to weigh things that are hot, you have to do this very nicely, in this case, in a vacuum chamber, which I do not have at home. And if you do it really well, I'm quite sure that you will find that there are many, many aspects to that experiment if you want to do it right. So it will degas and it will do all sorts of things. So it's by no means a simple experiment to do. And therefore I doubt that experiment, and it would have been much better to just really describe in detail what that experiment is that you do with the metal. That would actually really add something.
I tell you what.
So this is a very positive remark, but guys, because I tell you exactly what to do to convince people of that there is a problem. Because I don't think there is a problem.
I tell you what.
Yeah.
You said you are an accomplished experimentalist.
Yes.
Have you measured this thing before?
Yes.
Yes.
Yes. You find EOM.
Do you want to know what kind of things we have measured?
You find. Do you find when a metal heater is heavier?
Yeah.
Do you get that result?
Yes, I get the result that it gets lighter.
Wrong.
Yeah.
But
You
it
can
gets,
go home and do it again.
but it gets lighter.
I don't want to talk to you because I have talked to many people already. I mean,
Well, that was fun. All right, you want to try?
many people can do the
That's enough.
experiment.
One more. Do you want to
Not
try?
only you. I'm open to everybody to do this.
All right, go ahead.
I'm also looking for an experiment to see there are experiments which are not in agreement with Einstein's equation between energy and mass. And I would like to have a reference to an experiment. I can read this. You have 6 years ago we talked about it.
I'll send you. I'll send you that. I'll send you it, but it's good. Yeah. But anyway.
I'm proud of you, CY. You got everybody excited about physics.
Yeah.
All these 80-year-old people. Physics. Good job.
What I'm saying is, I don't mind people object. People can say I'm idiot or whatever they say. But I do request you go home and do the experiment.
Yes, go home. Do you have a home? Do you have a home?
Don't just listen to somebody. Do the experiment. That's all. That's what I tell you. I mean, you might first you get mistaken, and anybody can make mistakes. But my experience result is not my own. It's lots of people. And it's not only one experiment, 3 experiments shows Einstein is wrong. So it cannot be right.
That's good. All right, let's go to Lithuania.
Yes.